You've known this your whole life. Mirrors reflect light. It's one of those facts so obvious, so deeply embedded in how you understand the world, that questioning it feels almost silly. Of course mirrors reflect light. What else would they do? You use one every single morning. Maybe it's in your bathroom, fogged up slightly from the shower, your face appearing in it like it always has. Familiar, automatic, unquestioned. You've looked into mirrors thousands of times, tens of thousands. You've never once stopped to ask what's actually happening when you do. But here's the number that should stop you cold. A photon of light, the thing bouncing off your face and hitting that mirror, travels at 299,792,458 meters per second. It is the fastest thing that exists. 99% empty space. Let that land for a second. The atoms that make up your mirror are almost entirely nothing. The nucleus is vanishingly small.
The electrons orbiting it are probability clouds, not solid walls, not hard surfaces, not anything you'd expect light to bounce off of cleanly. If you could zoom into the mirror's surface to the scale where photons actually operate, there is almost nothing there. So here is the question you cannot answer yet, and I want you to really sit with it before we go any further. If a mirror is almost entirely empty space at the scale where light actually operates, what exactly is the light bouncing off of? That's not an answer. That's just a larger version of the same question. I mean, physically, mechanically, what object, what structure, what thing is reversing the direction of a photon traveling at nearly 300 million meters per second? You don't know. And by the end of this video, you will never look at a mirror the same way again. Your first instinct is probably this: light bounces off the mirror's surface the same way a tennis ball bounces off a wall. The surface is smooth. The angle of incidence equals the angle of reflection. The geometry works out perfectly. You learned this in high school physics, and it has never let you down. It feels right. It feels obviously completely right. And for objects at the scale we live in, it works beautifully as a description. But here's what that explanation quietly assumes without telling you. It assumes the surface is smooth at the scale where the interaction actually happens, at the scale of a photon. It isn't. When physicists image mirror surfaces at the atomic scale, using electron microscopes powerful enough to see individual atoms, what they find looks nothing like the flat, polished plane you imagine. At the nanometer scale, even the most carefully manufactured optical mirror looks like a mountain range, peaks and valleys, jagged, violent, irregular terrain. The smooth, silver surface in your bathroom, examined at the scale a photon actually experiences, looks like the Himalayas seen from ground level. A photon is not a tennis ball. It has a wavelength of roughly 400 to 700 nanometers for visible light. At that scale, the atomic roughness of even a perfect mirror is enormous. If reflection were simply geometric bouncing off a surface, like a ball off a wall, your mirror would scatter light in thousands of different directions simultaneously. You would see a bright, blurry, directionless glow. You would not see your face. You would never have seen your face. So that answer is gone, completely. Let's bury it. Now your brain offers you a second answer, and this one feels even better, even more scientific. You remember something from chemistry or physics: electrons. Electrons in metals are special. They're free. They can move. So maybe what's happening is this. The incoming photon gets absorbed by an electron in the mirror's metal surface. That electron gets excited, jumps to a higher energy level, and then re-emits a new photon. Absorption and re-emission. Clean, quantum mechanical, satisfying. And honestly, you're getting warmer. The vocabulary is right. The players are right. Electrons, photons, quantum states? Yes, you are in the correct universe now. But here is where this answer dies. When a single excited electron re-emits a photon, it does so in a random direction. That is not a metaphor or a simplification. It is a fundamental feature of quantum emission. A lone electron that absorbs a photon and then releases one sends it out isotropically, equally in all directions, with no preference for angle, no memory of where the original photon came from. If your mirror were simply a surface of individual electrons absorbing and randomly re-emitting photons, the result would be identical to the first failed answer: scattered light, Diffuse glow, no image. Your bathroom mirror would be indistinguishable from a white wall hit by a flashlight. But it's not. It shows you your face, sharp, precise, geometrically perfect, every single morning. So now you have no answer. The bounce model is dead. The absorption and re-emission model is dead. You are standing in front of an object you have used every day of your adult life, and you cannot explain, not even approximately, how it does the one thing you've always assumed it does. The mirror is, right now, a physical impossibility sitting in your bathroom, and you need to know what's actually happening. Here it is. Your mirror does not reflect light. It creates new light. That is not a poetic restatement. That is not a metaphor. That is the precise, literal, physical description of what happens every time you stand in front of it. The photons that left your face and traveled to the mirror's surface, those specific photons are gone. They are absorbed. What you are seeing when you look at your reflection is an entirely new population of photons, manufactured by the mirror, that did not exist a fraction of a nanosecond ago. Your mirror is a light factory. It runs on quantum mechanics, and it has been sitting in your bathroom this whole time. Now, how does it do it without scattering? How does it create new light that goes in exactly one precise direction instead of spraying randomly in all directions like a single excited electron would? This is where the metal matters, and this is where something extraordinary happens. The atoms in a metallic mirror, silver, aluminum, gold, are not holding their outermost electrons tightly. Those electrons are free. They don't belong to any single atom. They form a shared, collective cloud of charge that flows across the entire surface of the metal like a fluid. Physicists call this a free electron gas, or more precisely, a plasma. And this plasma is not passive. It is exquisitely sensitive to electromagnetic fields. When a photon hits the surface of your mirror, it doesn't interact with one electron. It interacts with this entire collective plasma simultaneously. The incoming light wave, which is an oscillating electromagnetic field, pushes and pulls on the entire electron sea at once. The whole cloud begins to oscillate together in perfect synchrony at the exact same frequency as the incoming light. This collective oscillation is called a surface plasmon, and it is the mechanism your mirror has been hiding from you. The surface plasmon is not a random event. It is a coherent, organized, collective quantum response, trillions of electrons moving together, in phase, driven by the incoming photon's electromagnetic field. And when a coherent oscillating charge radiates, when trillions of electrons swing back and forth together in perfect synchrony, the light they emit is not random, it is directed, it is phase-locked. It obeys the same geometry as the incoming wave, which is precisely why the angle of reflection equals the angle of incidence, not because of geometric bouncing, because of coherent quantum re-emission by a collective electron system. The law of reflection you learned in school is real, but the reason behind it has nothing to do with bouncing. It is the inevitable mathematical consequence of a trillion electrons performing a synchronized quantum oscillation every time light touches your mirror. Now let's go deeper, because once you understand the surface plasmon, a set of questions you've never thought to ask suddenly become urgent. Why does silver make a better mirror than copper? Why does gold have that warm yellow tint even in reflection? Why does a piece of wood, no matter how perfectly you sand and polish it, never become a mirror? These aren't aesthetic questions. They are questions about electron physics, and the answers are written in the atomic structure of each material. In silver, the free electrons respond to virtually the entire visible spectrum. Every frequency of light from violet to red triggers that coherent plasma oscillation with almost equal efficiency. Silver reflects about 95 to 99. That's not a pigment. The warm color of gold is the direct signature of how gold's electron plasma responds to quantum electrodynamics. You are seeing quantum mechanics every time you look at a gold ring. And wood? Wood doesn't have free electrons. Its electrons are locked, bound tightly to individual atoms and molecular bonds, unable to form the collective plasma that coherent reflection requires. When light hits wood, each electron responds individually, independently, randomly.
The result is diffuse scattering in all directions. You see a surface, not an image. No amount of polishing changes this, because polishing doesn't liberate electrons from their atomic bonds. The wood's atomic structure simply does not support the quantum mechanism that mirrors require. This is why the difference between a mirror and a wall is not a difference of smoothness, it is a difference of electron freedom.
Now push this one level deeper, because this is where the mirror connects to something that governs the entire universe. What is actually happening when those free electrons oscillate in response to incoming light? They are responding to an electromagnetic field. The photon that hit your mirror was not a particle in the classical sense. It was a quantized excitation of the electromagnetic field. And the electrons in your mirror are charged particles. They carry electric charge, and moving electric charge generates electromagnetic fields. The entire interaction happening in your mirror at its most fundamental level is described by quantum electrodynamics, QED, the theory that governs how light and matter interact at the quantum scale. QED is the most precisely tested theory in the history of science. Its predictions match experimental measurements to more than 10 decimal places. And every morning in your bathroom, you are running a live demonstration of it.
Maxwell's equations, written in the 1860s, decades before quantum mechanics existed, already contained the seeds of this. Maxwell showed that electricity and magnetism are two faces of the same force, and that light itself is an electromagnetic wave. What he couldn't have known is that the electrons in your mirror would turn out to be quantum mechanical objects, and that their collective response to his electromagnetic waves would be the precise mechanism behind one of the most familiar sights in your daily life. Electromagnetism is one of the four fundamental forces of the universe. Gravity holds planets in orbit. The strong nuclear force holds atomic nuclei together. The weak nuclear force governs radioactive decay. And electromagnetism, the same force that drives your mirror, is responsible for virtually every phenomenon you experience in daily life. Every time light interacts with matter, every chemical bond, every screen you've ever looked at, every color you've ever seen. Your mirror is not a curiosity. It is a window into the force that shapes almost everything you will ever touch or see or experience in your entire life. And now the part that should genuinely unsettle you. The same quantum process happening in your mirror right now, the surface plasmon, the coherent electron oscillation, the coordinated re-emission of new photons, is happening inside your eyes as you watch this. The cells in your retina contain molecules called photopsins. When a photon strikes one of these molecules, it triggers an electron transition, a quantum event, that initiates the entire cascade of signals your brain interprets as vision. You are not a passive observer of quantum mechanics. You are a quantum mechanical system, watching another quantum mechanical system, using a third quantum mechanical system to do it. Every image you have ever seen in your life has arrived at your consciousness through a chain of quantum events.
Light hitting surfaces, electrons responding, new photons being created or absorbed, signals cascading through neurons. There is no step in that chain that is classical. There is no step where the quantum weirdness stops and ordinary intuitive physics takes over. It is quantum mechanics all the way from the mirror to the back of your brain. And here is the thought that I want you to sit with for a moment. You have never actually seen yourself. Not once. Not even in your clearest, sharpest, most perfectly lit mirror. What you have seen, every single time, is a population of photons that your mirror manufactured, based on photons that arrived from your face. The face you've spent decades recognizing, judging, accepting, loving, criticizing. That face has never been directly observed by anyone, including you. What you know as your own appearance is a quantum construction, a re-emission.
The self you see in the mirror is, at its most precise physical description, a coherent quantum hallucination. Richard Feynman spent his life looking at the world this way, not to make it feel smaller, but to make it feel almost unbearably large. He said that the beauty of a flower doesn't disappear when you understand its biology, it multiplies.
You see the flower, and then you also see the physics inside the flower. And then you also see that the physics inside the flower is the same physics inside everything else. And suddenly, the world is not one thing. It is an infinite layering of wonder, each layer more astonishing than the last. That is what understanding the mirror gives you. Not a debunking, an expansion. So go back to the mirror, not the idea of it, the actual one. The one in your bathroom, the one you glanced at this morning without thinking, half awake, barely present.
That object, that specific, ordinary, unremarkable rectangle of glass and metal, is a quantum machine that has been manufacturing your identity for you every single day of your life. Every morning, it runs trillions of synchronized electron oscillations, creates an entirely new population of photons from scratch, and delivers them to your eyes in a configuration precise enough to show you the exact position of every hair on your face. It does this in less than a femtosecond, a millionth of a billionth of a second, before you've even registered that you're looking, and you thought it was just bouncing light. If this cracked open something in the way you see ordinary objects, if your bathroom mirror looks different to you right now than it did 10 minutes ago, then share this with someone who still thinks mirrors are simple, because the most extraordinary physics in the universe isn't hiding in a particle accelerator, it's hanging on your wall.
It has been there your whole life, waiting for you to actually look at it.